All right, so in this video we are going to condense the logarithms from 2 to 1 and then evaluate using the change of base formula. So you should know from the previous video that subtraction always converts to division when you have the same base. So this turns into log base 4, 7 over 10. So we have done the condensing part. And remember, change of base formula, we're going to use log base 10 to do this, but we're going to take log of 7/10 and divide it by log 4. Both of these, again, are base 10, so we can just simply put this in the calculator. Alpha y equals is handy here to put in a nice fraction. And again, we don't have to worry about putting anything for a base when it's base 10. And this will evaluate. Let's check to see if we can convert this to a fraction. We cannot, so we'll have to approximate that decimal. Let's do that to 3 decimal places. So that's negative 0.257. And remember, you can easily check this because underneath the math key, if you scroll all the way down, so underneath math, and you can choose log base, and then we can check this original problem by really just typing it in. You've got to show work, but you can always use this to check your answer. So I type in the original problem, hit enter, same decimal. So pretty easy to check these using the graphing calculator. Question 2, this time we are adding 2 logarithms. Addition converts to multiplication if you have the same base. Natural log, no different. So we're just going to multiply 12 and 2. So we condense these with natural log 24. And remember, natural log has an assumed base of e. So the evaluate part is just going to be the natural log of 24. Technically, we don't even have to divide by the natural log of e because the natural log of e is equivalent to 1. And then we can type this in the calculator. And yeah, there's the E button. Second division sign gives you the E button. And so this is equivalent to 3.178 to 3 decimal places. I don't think the directions say exactly what to round to, but as a general rule, 3 decimal places is good. And then we can check the answer. If we type in the original problem, the natural log of 12, close parenthesis, plus the natural log of 2, close parenthesis, we get that exact same decimal. All right, so the next one is a lot more complicated. I'm going to take care of what's on the inside of the parentheses first. So subtraction converts to division. So I'm going to keep the 2 on the outside. The log base 20 minus log base 4 is going to convert to log base 3.5 because I just divided the 20 and the 4. Plus, right here, we can use that third log property, which moves that multiplier out front to the exponent slot of 4. So this becomes log base 3, 4 raised to the 0.5 power or to the 1/2 power. And you should recognize that 4 raised to the 1/2 power is the exact same thing as the square root of 4 from our rational exponent lesson. So ultimately, this is going to simplify to log base 3, 2. And here on the other side, the same thing is going to happen. That 2 is going to move to the exponent slot of 5. So it's going to be log base 3, 25, because 5 squared gives us 25. And then finally, we've got 2 logarithms. Addition converts to multiplication, so that's log base 3, 50. So we've done our job. We've condensed this to a single logarithm. And then finally, all that's left is to evaluate this using change of base. So we're going to take log 50 and divide it by log 3. So log 50 divided by log 3. And we get approximately 3.56. And of course, this one can also be checked if you type in the original problem in the calculator. All right, so question 8. Here the directions are a little different. We are writing these as a single logarithm. So subtraction converts to division. So you can really only combine 2 of these at a time. So I'm going to combine the first 2, and that becomes log base 4x divided by 3. And then we're going to subtract. I'm going to go ahead and rewrite this one right here, log base 4y. And then I'm just going to use the subtraction property and divide one more time. So we got log base 4x divided by 3 divided by y. So we don't really want that. We don't like to have a fraction inside of a fraction. So we're instead going to multiply by the reciprocal of y in this problem to simplify it just a little bit. So I'm going to erase the y and the fraction bar, and instead I'm going to multiply by the reciprocal of y, which is 1 over y. So this becomes log base 4x over 3y. We do not have to evaluate. All we had to do there was to condense the 3 logarithms. All right, and then finally, question number 12. I like to take care of what's on inside of the parentheses first, so we're going to ignore the 1/2 just for a second and convert addition to multiplication. So this becomes log base 4 9x. Then I'll bring that 1/2 down and recognize that third property, which says when we have a multiplier out front like that, we can simply just move that to the exponent. But we've got to be careful here because we're not just raising 9 to the 1/2 power or x to the 1/2 power. We're raising 9 times x to the 1/2 power. So there's a number of different ways we could simplify this. But to me, raising something to the 1/2 is the same thing as taking the square root of all of this. So I'm going to rewrite it as log base 4 square root of 9x, and then I'm going to take the square root of 9, of course, since it's a perfect square. So this becomes log base 4 3 radical x.